So for this talk, I wanted to focus on something slightly different than a lot of talks in this space. So a lot of people like to focus on the designs of the protocols, which is like the fun, exciting part. But my focus at the Zcash company is more about how to make sure what we're deploying is safe. So I rely on other experts to do protocol design for a lot of the cryptography stuff. The bits of the protocol that I focus on are around safety, and also I focus a lot on the process we use. So just a bit about Zcash. Zcash is a permissionless blockchain with a cryptocurrency called Zcash. And it is based on Bitcoin in its design and its code base. And we've extended Bitcoin to have a new kind of transaction type which has really strong privacy. And that relies on something called ZK snarks, which is a novel kind of cryptography. So this is a little bit of a history. Down is in the past, up is towards the future. So when we launched in 2016, we call that version 1 protocol Sprout. That's what we have currently deployed. And pretty soon, we're going to have our first protocol upgrade, which is called Overwinter, which I'll get to in a bit. And then Sapling is planned for near the end of the year. Sapling is like a revamp of the cryptography, the core cryptography of the private transactions in our protocol. So it provides a few new features, but it's mainly much more performant, and it has stronger security. Okay. So yes, this is some early benchmarks on the difference between Sprout and Sapling. So if you've looked into Zcash at all, you may have heard that our first version protocol is really heavyweight. So for example, it can't run on mobile devices. So these numbers came from benchmarks on a desktop. So generating a transaction currently takes about 37 seconds on that machine, and it requires 3 gigabytes of memory. That's actually been cut in half since this slide was made, but it's still extremely large. So we've been putting a lot of effort into these performance improvements, which give us about 5 or 6 times in speed and about roughly 100 times improvement in memory. One thing to point out here, so Sprout was the first production deployment of ZK snark cryptography. So if you study cryptography or even learn a bit about it, there are many kinds of cryptography in the research that are not practical for production uses. And getting it down to practicality is sort of one of the later stages of research before you can make a product. So research scientists who created what was called the zero cache protocol were able to use ZK snarks to make something that they consider practical. So I showed you these performance benchmarks. Version 1 is like barely practical, right? It works, people are using it, it carries real value, and it provides strong security. But it has these drawbacks. It doesn't work on mobile phones or hardware wallets. This kind of R&D we've been doing to get like 100 times memory improvement is what you might expect from new cryptography that's just entering production use. So generally, these are a bunch of the challenges we were faced with deployment. So this is new cryptographic primitives. So that carries substantial risk. So it's been peer reviewed, it's scientific research, but it's never been put into production. ZK snarks are one of the only general purpose zero knowledge proving technology where the proofs are very efficient to verify and they're very small. So at the time that Zcash was deployed, they were basically the only technology available that could generate small transactions, which is necessary for a blockchain. You know, we're talking about layer 1, where transaction size is crucial. We're based on Bitcoin, and Bitcoin stimulated this whole space that we might think of as like incentive-compatible, permissionless consensus protocols, right? But this whole space is somewhat new in terms of being out in the wild for users to play with. So that was a challenge for us. Zcash is designed with permissionlessness and user autonomy as like fundamental concepts. So while my company does like consult on permissioned ledgers technology, for Zcash itself, permissionlessness is like a key requirement, just as it is for Bitcoin. User education is really tricky with, for example, key management and also privacy. And there's a large risk of just failing to execute. So we hear about many, many white papers. We see many ICOs raising lots of funds. But there's a real danger of failing to make something that actually gets deployed, achieves adoption, and is safe and doesn't harm users. So our approach, this is just a kind of a set of heuristics or guidelines about how we deal with these challenges. So for analyzing these new crypto primitives, we've relied a lot on scientific review. We have internal audits and external audits. And we have various kinds of belt and suspenders safety in the design of both our protocol and sort of the process for how we deploy things and how we communicate to users. And we do safety-focused stepping stones. So earlier when I showed this roadmap, there's Overwinter is activating soon. Overwinter is an upgrade to our protocol, what Bitcoin people would call a hard fork. And the whole purpose of Overwinter is just to make future hard forks safer. So you may have heard lots of controversy when Bitcoin was hard forking. There's issues like replay attacks, confusion about which chain should actually be called Bitcoin. There was a lot of controversy around signaling from miners about when different changes would activate. So for Overwinter, we focus just on making sure that in the future, if there is controversy, at least users can be safe. So it's not about us sort of like paving the way for our own roadmap. It's about anticipating in the future there could be controversy where different people want different changes to Zcash, and we want to protect users in that case. So ZK snarks rely on a global parameter setup. This is one of the main flaws with them. So I mentioned earlier they are the most performant in certain dimensions. So like the proof size is extremely small, which works well for blockchain transactions. But to get that trade-off, to get that performance, a trade-off is introduced, which is called a parameter setup. So there needs to be a set of global parameters that all users of the system agree on and know what they are. But the naive way to generate those parameters, like if you just generate it on a machine, ends up computing a value which would compromise the security of the system, specifically the soundness, but not the privacy. So what that would mean if that were compromised is that in the case of Zcash, you would be able to counterfeit Zcash. So our approach here is balanced with the failure to execute, the last risk I mentioned. So what we chose to do is launch something that we thought was minimally viable. So for example, we've some of our founders have started a new company called Starkware that's investigating a new kind of proving technology that doesn't have this parameter setup issue. And there are various other kinds of zero-knowledge proving technologies being researched really actively right now that don't have this parameter setup, but they have other trade-offs, of course. And so one thought is that we could have just waited to deploy Zcash until we had researched some of these new things. And if we did that, we would be basically betting on the results of research. And so it's hard to tell, will that take 1 year, will it take 5 years? By launching Zcash, which actually uses this technology, users can choose whether they want to take on that risk by owning or not owning Zcash. But in the meantime, I think we sort of have stimulated the whole ecosystem. So I think we actually have stimulated academic research into zero-knowledge proving that's trustless. And we sort of spurred on the industry to improve privacy. So I think this MPC approach is pragmatic. And so for our first launch, we had an MPC protocol run that we call a setup ceremony that involved 6 participants. And the security guarantees of that protocol would be that all 6 would have, you would have to compromise all 6 in order to compromise the parameters. For some people, that is too risky. It sounds too risky to use that as the foundation for a blockchain if it's supposed to be like a global cryptocurrency that's permissionless. That got us going. And for Sapling, which has the performance improvements, we've also improved the MPC a fair amount. So the new MPC is much more performant, and it can involve many participants. And there's a part of it that can be reused for other zk-snark applications. So once you've done this parameter setup, if you want to use zk-snarks in other applications, you can reuse these results. So this new parameter setup involves like dozens of people. I think it's on the order of like 40 or more folks so far for Sapling. In the future, we hope to upgrade to a system that doesn't rely on trusted setup at all, like no parameter setup. Coming back to the fact that Bitcoin is sort of opened up this new design space, one of our sort of technical strategies is that we don't innovate unnecessarily. So we are specialists at privacy and zero-knowledge proving technology, and as much as possible, we try to focus on that. So this might be in contrast to like Ethereum, which compared to Bitcoin, sort of innovates like on every possible axis simultaneously. It's providing smart contracts, new kinds of sharding, new kinds of consensus mechanisms, et cetera. Our strategy is be as much like Bitcoin as possible, because Bitcoin is very conservative and very stable, and innovate as little as possible. And so that's a strategy that tries to maximize safety. For permissionless and user autonomy, we do something at the Zcash company that I just coined as dumb governance tech. And so what this is we want users to opt in to using the system and to adopting upgrades. So each time they need to opt in. So for example, we don't have any sort of like auto update in our software, and users need to install a new version if they want to follow the new fork. That's just a simple example because it's like a lack of a feature. So we don't have auto upgrade. Running out of time. But this is in contrast to like more evolved systems that have governance built into the protocol. Let me continue. So some of this is a bit redundant. A little bit about security audits. We focus on several different specialties and areas of focus for security audits. So one is like traditional information security auditors who are familiar with things like buffer overflow vulnerabilities or how to spot traditional security vulnerabilities in C++ code. We also work with auditors who focus on cryptographic implementations in general. And then we also focus on auditors like CoinSpect who are Bitcoin and Ethereum specialists. So they know a lot about those consensus protocols. And then finally, there's several that we haven't announced yet who are on this slide, but we've been reaching out to different expert cryptographers in specific areas to look at specific pieces of our Sapling upgrade. Yeah, I'm out of time, but this slide is a bit about how we schedule upgrades in a way that's very far ahead of time. It has no signaling, so everyone knows like what date the activation happens. Anyone who doesn't upgrade, their software will exit, and it will explain to them that if they don't want to opt into the upgrade, they need to install something like another variant. And yeah, let's skip that. That's about governance in general, but that's it. I think I'm out of time, so thank you.